Hello everyone, we're going to start this video with logical operators. So logical operators are these symbols here. The double ampersand checks if two conditions are true. The double pipe is an OR, checks if at least one condition is true. The exclamation point is not, reverses, so it's like if it's true or if it's false, then it's going to run it. So let's create our first variable here, which is going to be a float temperature. We're going to create a Boolean sunny. And here's this temperature if greater than or equals to 0, and the temperature is greater or less than or equals to 30 degrees, and it's sunny, then we're going to print the weather is good. So you know it's got to be more than 0 degrees, less than 30, and it has to be sunny. If all three of those are true, then the weather is good. That's it. None of them could be false. So otherwise, the weather's bad. So we can see the weather's good because the temperature is 25 and sunny is true. So 25 is in between 25 or in between 0 and 30. So if we're to put sunny to false, that means, you know, the weather is not going to be good anymore because it doesn't meet all three of those. So the weather is bad. But now what if we put in a double pipe for OR? So it doesn't matter if it's sunny or false. You know, it could be -5, but as long as it's sunny, then the weather's good. So if we run this now, I mean, we've got sunny set to false, but we're saying, you know, if sunny is true, it's going to say the weather is good, even though it's not sunny. So now in order to do the not, the reverse, then we can see here it says the weather is bad because obviously it's not sunny. But if we put it to true, by the way, you got to use this std bool to be using booleans, like true or false statements. You got to use that std bool header. So now that's true, it's true. We can hit run. It's going to come the weather is good because that's all it needs. And you know, if we put it to a 1, it means the same thing as true. If we put it to 0, it means false. So, you know, if we put 1, it means true. And if we just put sunny, then it doesn't matter. It's just true. That's just default, so it's going to work. And if we put an exclamation point in front of it, it's going to reverse it. So now you see the weather is bad. So let's go on to the next segment, which is the functions. I'm going to be talking about dry code. Dry code means do not repeat yourself. So DRY, don't repeat yourself. And that's what functions are for. We're going to put our include, our headers, and here is our main block. And we're going to do a function that prints out, may the real Hungarian nerd please stand up. We got to print it out 4 times for this to come up. So, you know, in order to update it, we got to change it on every single one. So we got to update all of them manually just to change that function. But there's a better way to do that. There's a way to edit it from one centralized location instead of 4 different locations. And that's where the functions come in. So let's go ahead and create this function. So you type in void to kind of invoke the function. Then you name the function whatever you want after. So I'm going to name it nerd. That's just my name. So void is an actual name that C recognizes, but nerd is not. Nerd is just the name I'm giving it. So this is what this function is going to do. It's just going to nerd. So now we could delete this whole thing. and we just type in nerd. So now if I run that 3 times, it runs it 3 times, and that's all I got. It's way easier to type in. And now if I want to change it to, like, let's say the real Daffy, please stand up, I only have to change it in one location. So it's a faster way of doing things, and makes it easier to keep track, making sure you don't miss anything when you're going back to edit or debug or update some code. So now let's get into arguments. So here we're making another function with the void invocation for a function. We're making a character, and we're just going to do a level and like a class. So this is a void invocation for a function. So we'll create our main block here. Our character, the first variable is going to be a string called char, or character, and it's going to be the class. So we're going to make a warrior. And for the level, we're going to put in our integer. Let's say level 14. Then we've got our character function. So now if I play this, it just says you are level X, you are Y. And it's not putting in the values that we gave it. And it's not doing that because we've got to specify in the main function block what these variables are. So they're not linked up yet. They're not synced. So instead of putting in an X, we're going to put in %d for decimal or integer. And then we're going to specify what integer we want to pass into there. So we want to do the level variable that we got later on in the script. And then we're going to use S for the character or string. And this is going to be the class. So we're going to assign that, make sure it's synced up. So the character, now in these parentheses, we've got a spelling mistakes. We've got to specify our integer and the class that we're going to be passing into that function. And same thing in the main block, we're going to pass in the variables and the types. So just like that. Now that we run it, it says you are level 14 and you are a warrior. So that's the kind of our character. And we can replace the class and level with a y and an x as long as we do it in the function invocation and in the function parameters. So down here as well, you just got to match it up. And now it's all synced up, so we hit play again, and it would run it again. So let's talk about return statements. So here we've got the void invocation for a square, and we're going to be talking about a double. So a double result equals x times x, and we return the result, which this isn't going to return anything yet because we haven't printed anything out yet. The x's are just just placeholders for now. So in the main block, we're going to be calling upon this square function that we created with the void, and the LF % is for double. And, I've got the double quotes messed up. So anyways, then we've got the ternary operator. So ternary operators are a shortcut to if-else statements when you're assigning, returning a value. And then the condition it's like a shortcut to if-else statements, like returning values, assigning values. And we've got conditions like a question mark is like a value if true. So the question mark is asking if an argument is true or not. So you can kind of put that into an if-else statement. So this can be a find a minimum number function. So if x is greater than y, return x, else y, else return y. And if the return x is greater than y, then the question mark is asking if this argument is true of where x is y. So we'll do this x, integer y. So we're passing in these letters as integers. So if we run this, we can see that 4 is the bigger number. So I've actually got to flip these around. Yeah, there you go. So now if I run this again, it's going to give me a 3. And that's the minimum number. So let's activate this return statement, the ternary operator. And we can deactivate the rest of it just to show you that this does the same thing. Now we just flip this around again because I got it backwards. So this one line does the same thing as those other lines, like this whole other block. So you can get rid of this whole block here and replace it with just one line, and that's the ternary operator. So, you can make things a lot neater, optimize it with just one line instead of having, how many lines is this, like 8, 6 or something? All right, now let's talk about function declaration, function prototype. A prototype of a function is the declaration without a body before the main, and it kind of helps you ensure that calls to a function is made correctly with the right arguments. So let's go ahead and go off the RPG thing. So we got a warrior, we've got the level. Here we're creating a character pane, which is our function variable. It's going to be the class. So here we're going to create a function here. So this is the character pane, and we've got a class, we got the integer, and it's just saying hello. This is the class. You are level this, and it's syncing up the variables to the print function characters. So instead of having it at the top, we're going to put that void underneath the int main. So if we run this just as it is, it's going to give us an error, but it's still going to give us the number, which is like 4 million, which is way too much. So that's because we don't have the prototype created before the main variable. So now we got to create the prototype, the function declaration before the main block. So it kind of looks the same at first, but here we're assigning it the character type, and it's going to be an integer, so a bit less to the point. So now you can see you're level 21, hello warrior. And this is kind of how, many C compilers don't check for parameter matching, and missing arguments will result in like some unexpected behavior. And a function prototype causes the compiler to flag an error if arguments are missing. And it's just easier to navigate a program with main at the top and with the prototypes above it and the functions after it, because it just helps with debugging and commonly used in header files. So there you go. The top, that's the prototype. Then we got the int main, which calls upon the prototype. And after the main block, it uses the rest of the function. So now let's get on to string functions. So we've got our main, we've got the string.h header file. We've got two variables. String 1 is Hungarian, string 2 is nerd. And here's our print statement. So as you can see, we print it, and I gotta put in a close bracket and a return. So there you go. Print just prints out string 1. That's it. That's all it's printing out. Now this first one, if we activate it, it says string lowercase. Let me switch these around. So you just see it puts the capital H to lowercase h. Second one is uppercase, so it makes it all uppercase. The third one here, string cat, it just appends string 2 to the end of string 1. So now we got Hungarian nerd. We attach string 2 to the end of string 1. String n concatenate, it attaches one number, so like the first letter. So the 1, this one here, is whatever number you give it, but it's like if it's a 1, it puts in the first letter. If it's a 2, it puts in the first 2 letters. If it's 3, it puts in the first 3 letters. So here, if you do 3, it says Hungarian ner, because ner just the first 3 letters of nerd. And then, so this one string copy kind of overwrites it. So it puts string 2, copies it onto string 1. So now string 1 is just nerd. So the same thing here, except it just copies the first 4 letters. So now it's like Nerdarian, because we copied over the 4 letters of nerd onto the first 4 letters of Hungarian. And if we just put that to a 1 now, it's just going to replace the H, which is the first letter, with the first letter of nerd. So that's how that works. So here's some more functions. Let's activate this one. And the first one is sets all of the characters in string 1 to 1 character. So if I run this, I get all question marks. The next one sets the first number of a character to a question mark. And if I were to put this as a 4, it's going to set the first 4 numbers, or first 4 characters to that symbol. This one reverses it. This one reverses it, pretty straightforward. This one returns the string length as an integer, and as you can see, it returned it twice as a word because you actually got to change this. Because right now it's returning an S, which is a string. We got to return a D. And then we've got to update the string 1 variable, because if we don't, it's just going to give us a random number. So we've got to update this to result, which is the variable that we used above it. So now it says 9. That sounds more like it. Next one is comparing the strings. So -1 means that they're not the same. So if they're the same, they should give us a 0. So here we could put in an if statement. And, if it brings us back a 0, which it did before, it'll say these strings are the same. So that's going to print out. But if we go back, change it back to nerd, we know it says a -1. So that means that's not a 0, a -1, right? So if we hit play, it's going to match it up and say that's not a 0, so I'm going to do these strings are not the same. Now this one, these strings compare the characters, and that just means like, so if I put a N-E-R, then we can compare the first characters, and it'll say these are the same because the first 2 characters are the same. This first 2, these are the same as well. The first 3, these are the same. But if we do 4, then they are not the same because, as you can see, a G and a D are not the same because that's the 4th slot. And this one is the same as this one, but it just ignores the case sensitive. And this one is the same as this one. Again, just ignores case sensitive. So now let's talk about for loops. So for loops repeats a section of code a limited amount of times. And here we got for int. Index is just a common to replace index with I. That's just like a standard thing that programmers do among the community. Index is not a word that C understands by itself. It's just a name that we give to a variable or to a function. So that's just, it doesn't mean anything. It just, don't overthink it. We just use it a lot, and it's just a common name. It's like someone's last name is Smith, you know? We just put I for numbers. So I equals 1, and this is gonna run as long as I, for every time that I is greater or less than or equal to 10, and then it's gonna add 1 to I. So now it's gonna print it by 10, it's gonna print the decimal, we're gonna assign the decimal value to the I index that we put up here. And then after that, we're gonna replace that with a couple other things just to play around with it. So now let's hit play. We can see it's going to print by 10, and then every time it's going to raise it by 1. So now if we do this plus equals 2, it's going to raise it by 2 every time. So it goes 1, 3, 5, 7, 9. It doesn't go to 10 because the next one would be 11. It's just going to stop then. So if you actually want it to be 10, then you've got to replace the 1 with a 0. And then it counts up from 0, so it's 0, 2, 4, 6, 8, 10. So now you get that 10. And you could change this to a 5 as well if you want. So 0, 5, 10. And you can also decrement it, so you can make it go down. So to do that, you just flip everything. You make everything opposite. So you flip this around, make that a 0, then you do minus minus. So now it counts down from 10 all the way down to 0. And then we could do minus equals 2 to make it count down by 2s. And that's all it is. So now we're talking about while loops. So for while loops, it might repeat unlimited times. It runs while some condition remains true, and while loops might not even execute. We'll check it out. So for this one, we're going to make a character variable called username with number 20. The 20 is the user input limit, because we're going to get some input from ourselves here, and 20 is going to be the maximum amount of characters we could put in. So we got print what's your name, fgets takes the user input. It's like scanf, but scanf doesn't like spaces, and we're going to want to have spaces in here. So we'll just do fgets instead. And it takes the username variable, maximum 20, and the standard input of what the user is going to put in. This line here takes the string length of the username, and it's got a -1, which is going to equal 0, which is just, this is kind of like a placeholder for a null character, like the default, which is 0. If you don't get any user input, it's kind of like a catch block so the program doesn't error out. So you could just run the program even if there's no user input. So here it says, what's your name? It says Tim, hello Tim, and that's what that print at the bottom does. So, but here, check this out. If we do what's your name and don't enter anything, it just says hello. This is where the while loop comes in, because the while loop, we can force the user to put in a name. Gonna make them so it's gonna run this code up here, and before it runs this print statement at the bottom, it's gonna go through this while loop to make sure that it can proceed to the print hello. So we're going to do the string length username equals 0. So while the string length equals 0, we're going to say you did not enter your name. What's your name? And we're going to prompt the user one more time for the name. So this is the exact same thing we wrote up there. We're just getting the user input again. We're defaulting it to 0. We're defaulting that null character at the end here. So same thing that it's doing up here. We're just doing it one more time here in the while statement, just to make the user put in a name. So now if we hit play, it says, what's your name? And if I hit enter, it says you did not enter a name. And I can hit enter as many times as you want, and it's going to sit here and bully me and force me to put a name in. So I put in Tim, says hello Tim. So that's awesome. It works. But now this thing here, it's kind of a waste of space because we already have it down here. So kind of like really extra code that we don't really need, right? Let's clean this up with something called a do-while loop. So a do-while loop, to get this initiated, we put in an if statement of the string length. So the if statement is checking the string length, and it's going to be our error handling, where it says, you did not enter your name. And we're going to put this while at the last bracket. In the first bracket, we're putting do before the bracket, and then we could delete this. Now, if I hit enter, it says, what's your name? And if I don't put anything in here, then we got to play around with the little options here. So, what's your name? So if we put both signs as equal to 0, now we can do this statement. So let's run it. What's your name? You did not enter your name. If I put in Tim, hello Tim. So now this is a do while statement. Now let's get into nested loops. A nested loop is a loop inside of another loop. So let's create some variables here. We're going to kind of create some kind of like a database looking thing. We got rows, columns, and then we're going to put in symbols. So we've got a print and a scan for enter a number of rows for user input. So D is going to be our decimal point or an integer for rows and for columns. And now we're going to do for. This is going to be our inner loop, or outer loop, I mean. So we're going to have an inner loop and an outer loop. So the inner loop is going to be dedicated for rows, and the outer loop is going to be dedicated to columns. And the outer loop executes for each row. So for here, we've got I equals 1, so I is the index. And the column, we're going to use J, just because J is the next letter, the preceding from I in the ABCs. So kind of how, you got hurricanes in Florida, you got Hurricane Ivy, and you got Hurricane Juliet, and it kind of just goes along the alphabet every time a new hurricane comes out. So that's kind of how we're going to be naming our integers here. So, integer J equals 1. For every time int is 1, it's going to, as long as I is greater or equal than the rows, then it increments. As long as it's greater or equal to the columns, then the inner loop is going to increment. And I'm going to need my include. So, wow, that wasn't supposed to happen. I got an infinite loop there. It just hit Control C to stop it, but hold on. All right, now I hit run and now it's working, even though I didn't change anything. So I don't know why it did the infinite loop, because I didn't change anything and now it's working. So maybe something was cached. Maybe, I don't know. So let's enter number of rows, which is 5. Then let's enter the columns. Let's do 2. So now we've got 5 rows of 2 numbers. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 5 times, right? So we can fix this, make it look a little nicer just by putting this print return. We're going to do this carriage return here. It would help if I spelled print right. There you go. So now enter number of rows 5, columns 2. Now we got 5 rows in 2 columns on each row, right? So that looks a bit nicer. It makes more sense now what we're doing. Kind of hoping it's coming together now what rows and columns is meaning. So now let's go into getting the symbols introduced. So a symbol, we're going to use %C for one single character. We're not expecting a string, we just want to see just one character. And we'll replace this J with symbol. So now we hit play, and I do 5, 2, and now I get a blank thing. Now I'm getting a similar thing to like that never-ending loop thing. And I think that's because of some cache or some buffer overflow or something. Some kind of bug is happening. So here we're gonna try to just clear the buffer before it runs the inner and outer loops. So we'll do a scanf and we'll just do a blank kind of we'll place in our symbol for the %C. Just a character. So let's try this again. Enter rows 5, columns 2. Symbol, we can use, let's say, a £. And as you can see, it replaces all of our numbers with a £. So that's pretty cool. Those are nested loops. Now let's talk about continue and break statements. So here's just a standard block, for I equals 1. As long as I is greater or less than or equal to 20, then it's going to increment by 1. And here is our decimal with a new line. Then the I syncs up to the value we have in the function. And this is just going to count all the way up to 20 whenever I figure out how to spell print properly. So there you go. It goes all the way up to 20. And we can actually make this a little bit smaller of a number too. So if, here we can create an if statement. So if I equals a specific number like 7, then continue. So what this is going to do is it's going to count up and it's going to loop around to count all the way up. And continue skips the rest of the code and forces the next iteration of the loop. So it's going to get to 7, and then it's not going to do the rest of the code. Instead, it's just going to skip, continue, and go back to the beginning of the code and run it over the loop again. So the way this looks is we hit play, and it counts 1, 2, 3, 4, 5, 6, 7. No 7, just a 8, 9, 10. So, when it hits that 7, it just skips over it, but it continues and it finishes the program. So we could comment this out to deactivate it, talk about break. Break just exits. So, if it hits the 7, it's just going to stop the program. It's not even going to print out the 7. It's just going to hit the break, and it's going to disregard that print statement afterwards. Because see, the print comes after the counting, right? And so when it says a 7, it just breaks out, stops the program, and it just stops at a 6. So I just want to show you guys this new keyboard I got. This is the Keychron Q9, and I thought it was so cool, unique, and cute that it didn't have any numbers on it, and it was so tiny. But it's got to be a novelty item because it's the most inconvenient keyboard. Like I've been making so many spelling mistakes, and it's tough to type, and I've been trying to copy paste things, but I know there's like different functions, and you could program in different layers of the keyboard. I've been using this for 3 weeks now. I'm kind of getting the hang of it. I had to switch out some of the keys to have the numbers here just to like kind of keep track of where things are. But it's been a struggle, and I feel like even if you get really used to this thing, that your keys, your words per minute is gonna go down either way because you gotta press more keys to switch the layers in, and then sometimes if you do Control C on the wrong layer, you end up like deleting your whole thing or refreshing the page you typed out a whole essay on, and it's more of a nuisance and more destructive than anything. It just kind of like it's just a novelty. Like bring it to Comic-Con, bring it to a computer convention, but if you actually want to get work done, you want to be productive, I would say just stick to a normal keyboard. Yeah, I'd like to thank you guys all for watching. Hope you found some value in this video, and I'll see you on the next one.